Hello, ladies and gentlemen, and welcome back. We're looking at question number 24 in this video on our 2013 Grade 8 Gauss competition. In any triangle, the length of the longest side is less than half of the perimeter. So this is true. In fact, in order to make a triangle, all you need are three sides. Of course, you knew that. But you also need the longest side, C here, to satisfy this inequality. The C has to be less than the sum of the other two sides. This is what's known as the triangle inequality. Because, of course, if you have like a really long, like 7 for the longest side, and then you have sides of length 1 and length 3, they're just too short. They can't actually meet and form a triangle. So if you have this relationship, you can always get a triangle. And from there, if we add C to both sides, you get A plus B plus C, but that's the perimeter. So 2C needs to be less than the perimeter, or C has to be less than half the perimeter. And that's just a nice general rule. So they're telling us that in the question. We don't actually have to prove it, although we clearly just did. Okay, so longest side is less than half the perimeter. All triangles with perimeter 57 and integer side lengths x, y, and z with x less than y less than z. So you'll notice 57 is 3 times 19. We could not use the equilateral triangle, or we're not talking about the equilateral triangle with 19, 19, 19 here, because they're specifically asking for x, y, and z to be different numbers. X is less than y, is less than z. All right, so we're talking about all the triangles with perimeter 57, integer sides, and the integers are all different numbers. And these are all constructed. How many such triangles are there? Okay, now they're being nice and telling us about the longest side, so I might focus my initial efforts on this z. So we know x plus y plus z, these are the side lengths. They have to add up to 57. They're telling us the perimeter. They tell us in the question, although we could probably have worked out, z has to be less than half of 57. And since z has to be an integer, half of 57 is going to be 28.5. So z is at most 28. Okay. So this gives us a value of z that we could focus on. Now, what we might do is just sort of break it up into cases. So, if z is 28, what could x be? What could y be? And still have a perimeter of 20 or of 57. And then, well, if we're going to do that approach, we should probably figure out the lowest z can be. Now, if we've got x less than y less than z, the best that you can be is x is 18, y is 19, and z is 20. That'll get you 57 with all of them different, because, of course, the smallest that your longest side can be if your perimeter is fixed is if you've got an equilateral triangle, and that would be 19, 19, 19. But we can't have that. So, and we can't have the longest side be 19, because if z is just 19, then these others would have to be less than that, and that wouldn't add up to 57. So the smallest z can be is 20, and that's if we get exactly that triangle right there. So this isn't too many cases to check, as long as we reason it out. So they're giving us sort of the 28 in the question, and we deduce that after a little while that 20 is the lower bound. So now we might start trying to figure out triangles. And I'm going to start at the bottom. So if z is equal to 20, well, there's really only one triangle you can make. Y is 19, x is 18. So that's going to be one triangle. Hurrah. Now, if z is 21, well, this might be a good way to do it. So we know the perimeter. So we know x plus y must be 57 minus our z. And then we can ask, all right, values of x and y. So 37 here. And 18, 19 for y. So 36 will have to be the sum of x and y. But we know that y has to be less than z, so we couldn't have y be 21. Maybe y is 20. So x would be 16. Or we could have 17 and 19. 18 and 18? No, because the sides have to be different. So we get two triangles if we're looking at 21. What if Z is 22? So if the longest side is 22, then that leaves 35 for the remaining sides to add up to in order to get that nice fixed perimeter. Okay, well, how do you make 35? Well, y can't be 22, so y at most could be 21. Trying to stay organized, trying to be orderly about this. So x could be 14, that would add up to 35. And then once we've got 1, you just sort of subtract 1 from the y and move it over to the x, because they have a fixed total that they have to be. 17, 18, so that gives me 4 triangles. And I mean, we're through 3 of these already. Only a few more to go, so I don't think it's going to be that bad to just enumerate them. If there were a pattern emerging, like 1, 2, 3, and the next one's 4, we could probably do a short formula to get the answer. But 1, 2, and 4, unless the next one's 8, I'm not seeing a particular pattern. But that's okay. We can maybe speed up a little bit. So 34 is our new total here, yeah. So at best, y can be 22. And that would make x 12, or 13 and 21, 14 and 20. Now, what's the best they could do? Well, eventually it could get down to 17, 17, but you're not actually allowed that one. So 16, 18 would be the best. And so one way we could speed this up, I've got 5 triangles here right now, is to say, all right, we know what z is, so that gives us 1 less than that will be the best y can be. As long as there's a corresponding x, we can write it. So here's our z, 24. So we'll have to have 33 as our sum. So 23 and 10, that's the best you can do. Now what's the closest x and y can be? Well, 16, 17 would be the best. And now I don't need to write all these ones in the middle. I just need to know, well, how many of those are there? Right? 10, 11, 12, 13, 14, 15, 16. There's going to be 7 of these. I don't actually need to write them all out. So far we've got 1, 2, 4, 5, 7. Let's keep going. So if z is 25, then we're going to have 32 for our remaining amount. So at best we could have 24 and our x could be 8. Now you'll notice the x's are getting smaller. We might actually reach a point where x could be 0 or negative. We're going to have to watch out for that because you can't actually have a side length of 0 or a negative side length or anything. So 8 there. And then what's the closest? Well, the closest we could have is 16 and 16. But then those would be the same. So 15 and then the y value being 17. That's the best you can do. Still get 32. So how many numbers are there from 8 to 15 inclusive? Well, 15 minus 8 is 7 plus 1. Anytime you're trying to figure out how many numbers between m and n, as long as you're allowed to include the endpoints, it's always n minus m plus 1. So 15 minus 8 is 7 plus 1. There's going to be 8 of these. I don't actually have to write them all out as long as I trust my calculations. So for 26, the sum would need to be 31. The best y can be is 25. And that would give us an x of 6. And then the closest they can be would be 15 and 16. Divide 31 by 2, you get 15.5. So put the x a little bit lower, the y a little bit higher, and you're good to go. So how many numbers between 15 and 6 inclusive? 15 minus 6 is 9, plus 1 is 10. Okay. So we keep going. If z were 27, and then finally 28, well, we're almost done. So if we'll have 30 here, the best that y can be is 26, so x would have to be 4. And the closest they could be, 15, 15 doesn't count, so it'd have to be 14, 16. How many numbers between 4 and 16 inclusive, including the endpoints? 14 minus 4 is 10, plus 1, you'll get 11. You can write them all out if you want to. Don't waste your own time, though. All right, 28. So the sum would have to be 29. So the best that y could be is 27. So x would have to be 2. The closest that we can get is 14. And a y value of 15. And the numbers inclusive there, 14 minus 2 is 12, plus 1 is 13. Okay. So now we just need to add this all up. 1 plus 2 plus 4 is 7, plus another 7 is 14, plus 5 is 19. Then 19 and 18 is 37, then plus another 24. We can even just write this down. 1, 2, 4, 5, 7, 8, 10, 11, 13. So those two are 24. That's 18. Combined, that would be 42. That's 7. That's 12. So that's 19. 1, carry the 1, so we're looking for 61 is my answer. Now, if I don't see 61 presented, it means there might be an error in my calculations, but I do see it. 61 is sitting there. It's B. So we will bubble in B for question number 24. We've got one more question to go. That'll be question 25, and I will see you for that in the next video. Until then, take care and have a wonderful day.